Hello, welcome back. This is lesson 6.2, and we are on the second page, which is page 143. And we are talking about graphing exponential functions. So in the previous page, we saw the graphs of 2 to the x, 3 to the x, and e to the x all together. We saw that all of these graphs have, all of these functions have a base that is greater than 1, and then the graphs are always increasing. Now, let's see what happens when we have a base that is not greater than 1. It is between 0 and 1, such as 1/2. So the first thing I want to say is that we can also rewrite this function in the following way. If we think about 1/2, it's like 1 over 2 to the first power, right? So I'm just rewriting what's inside of the parentheses, which is the base. And I could move that to up, and then the power would become negative to the x. And then rules of exponents say power to a power, we multiply the power, so 2 to the negative x. So turns out that these two expressions, which I'm going to highlight right now, this one and this one, are actually equivalent. Okay, these are the same. So then clearly the graphs are going to be the same. Now let's see what happens. And I'm actually going to look at, let's say, this version, 2 to the negative x. Okay, we just learned that that's the same thing. So if we do 2 to the minus negative 3, this is really 2 to the positive 3, which is 8. And then 2 to the minus negative 2 is 2 to the second power, which is 4. So then this one here is going to be 2. Now, if we do 2 to the 0 is 1. And then 2 to the negative 1, let's take a look, 2 to the negative 1 is 1 over 2 to the 1, so we have 1/2. So then that means that the next ones will be 1/4 and 1/8. So if you look back at the previous page, at the previous video, you will see that the order in which these outputs are is now reversed, okay? When we have 2 to the x, we start from smaller y values to greater y values, meaning the graph is always increasing. But now we can see the graph as we're moving from left to right, the y values are decreasing. And let's see that on the graph. So we start with -3, and we go all the way up to 8, then come down to 4, come down to 2, come down to 1, 1/2, 1/4, and 1/8. So it's very much the same curved shape than 2 to the x compared to 2 to the x. But this one here is always decreasing. So this, let's make a note. We can see this graph is always decreasing. And we have a horizontal asymptote in exactly the same location. So its equation is y = 0. There is no vertical asymptote, same as the increasing version of this function. And the domain and the range are the same. Domain is all real numbers, and the range goes from 0 to infinity. And I think those are the most important things. Now, here is a summary of what we have learned with the graphs on the previous page, and now this graph in this page. If the base is greater than 1, we are going to have an always increasing. But if the base is between 0 and 1, then this graph is decreasing. Now, both go through the point, and it's kind of tiny there, so I'm going to make it bigger. 0, 1, and that's going to prove to be an important point when we start graphing. It's going to be a good reference point to always keep in mind and keep track of where it is as we maybe do reflections and other types of transformations. Now, there are a couple of things that are exactly the same. So the horizontal asymptote for both is y = 0. Both of them, or neither of them, has a vertical asymptote, and then the domain is all real numbers, and the range is from 0 to infinity. Okay, so we have these three aspects that are the same for either one of the versions, right? The always increasing or the always decreasing. Okay, so we have finally our first example where we're just going to determine, without putting this graph on a grapher, if the graph is increasing or decreasing, and we need to say why. So going from left to right across the first row, well, this first one is going to be decreasing, which is right, DEC for decreasing. We can think about this as 7 to the negative x as well. So, you know, like that would be one way to demonstrate, you know, that negative power means that the graph is decreasing. Or we could say that the base is between 0 and 1. Now, for the next graph, this is going to be increasing. And the reason is because 5/4, which is the base, is greater than 1. The next one, gotta be careful not to be fooled. It's the same numbers, but the fraction is the reciprocal of the previous one. So this is decreasing, and that will be because 4/5 is between 0 and 1. Then we have 1/3 x, which very similarly 1/3 to the x, which very much like the problem number 1 could be written as 3 to the negative x. So this is decreasing, and we could say that that is because 1/3 is the base and it's between 0 and 1. Now this one, gotta be careful, because if you just look at the negative power, you might say, ooh, decreasing. If you just look like at the base, 1/3, which is between 0 and 1, you might also say decreasing. However, if we think about 1/3 as being 3 to the negative 1, and then we have a power of negative x, well, this actually becomes 3 to the positive x. So this is really an increasing function because the base, 3, is greater than 1. That one can be tricky. And then this one here, well, it's pretty much like more of the same. It's clearly a base that is greater than 1. So this means that we have an increasing graph. And that's it. I'll see you on the next video in a little bit.